Hi my dear students, have you completed the notes for the last video? So I think you have watched two videos from real numbers. So you have completed notes for two videos, am I right? Okay. Now we are moving on to the process, now move on to the step. So in the last class we have discussed decimal numbers and its types. The decimal numbers are the first type we have completed. The first one is terminating decimals. Terminating decimals means the digits in the decimal part stop. They can stop. So how can we convert into the rational form? How can we convert into the decimal form? Also we have completed. Already we know that we have learned in the 7th class and the previous classes. Also we have completed in the last video. So that means I will explain once. For example, we have the number 1.05. 1.05 is a terminating decimal. The digits in the decimal part are only 2. So after 5 there is no other digits. So it was stopped at 5. So if you want to convert into the rational form, we are writing we just remove the decimal point. We are getting 105 divided by, there are 2 places in the decimal part. So we are writing 100. So if we cancel that 5 table, it becomes 21, it becomes 20. 21 by 20 is a rational number we call as a fraction. So we have learned in the earlier classes like 5th class and 4th class and 6th class also. So we can convert the decimal number into the fractional form like this. So we just remove the decimal point, we are getting 105. So there are 2 places in the decimal part. So we are writing 100. If you cancel the 5 table, we are getting 21 by 20. This is the form of terminating decimals as a convert terminating decimals as rational numbers like this. 1.05 becomes 21 by 20. 21 by 20 is in the form of p by q, where denominator q is not equal to 0. This is the rational form. 1.05 is a terminating decimal. So we have successfully completed in the last class. I will give the homework in this video by last session. So now we have to learn. I told you decimal numbers are 3 types. The first one is terminating decimals and the second one is, so now we are learning non-terminating recurring decimals. These are non-terminating recurring decimals. This is the second type of decimal numbers. I want to remind you, decimal numbers are 3 types. We have to revise this type. 3 types. The first one is terminating decimals. And the second one is, we are adding terminating to the word non. Non-terminating. Terminating means stop. Non-terminating means does not stop. Non-terminating, those are recurring decimals. Terminating decimals, and if we add non to the terminating, we are getting non-terminating recurring decimals. And the third one is non-terminating and non-recurring decimals. These are the types of decimal numbers. Actually, decimal numbers are 3 types. The first one is terminating decimals, and the second one is non-terminating recurring decimals, and the third one is non-terminating non-recurring decimals. So we have to learn one point. Terminating decimals and non-terminating recurring decimals are rational numbers. They are in the form of p by q. We can write these 2 decimal numbers in the form of p by q. So already we have discussed how can we convert the terminating decimals into p by q in the last video. So in this video we have to discuss non-terminating recurring decimals as in the form of p by q. How can we express non-terminating recurring decimals in the form of p by q? And the other one is non-terminating non-recurring decimals. Non-terminating non-recurring decimals are irrational numbers. What are that? Irrational numbers. I told you already the definition. What is irrational number? The numbers which are not rational are irrational numbers. The numbers which are not rational, ఏ numbers అయితే rational numbers కావో ఆ numbers ఏమవుతాయంటే non terminating నాన్ రికరింగ్ డెసిమల్స్ అవుతాయి. సో రేషనల్ నెంబర్స్ డెఫినేషన్ ఏం చెప్పాం? ద నెంబర్ విచ్ ఆర్ ఇన్ ద ఫార్మ్ ఆఫ్ p by q. ఇర్రేషనల్ నెంబర్ డెఫినేషన్ ద నెంబర్ విచ్ ఆర్ నాట్ ఇన్ ద ఫార్మ్ ఆఫ్ p by q. Okay na? So if you tell the definition for rational irrational numbers by using decimal expansions, the number which has non-terminating non-recurring decimal expansion is called irrational number. Did you understand? A number which has a number kaithe non-terminating non-recurring decimal expansion untado a number irrational number avutundi. ఏ నెంబర్ కి అయితే ఏదో టెర్మినేటింగ్ డెసిమల్ ఎక్స్పాన్షన్ ఆర్ నాన్ టెర్మినేటింగ్ రికరింగ్ డెసిమల్ ఎక్స్పాన్షన్ ఉంటుందో దట్ ఈస్ irrational number. Did you understand? So we have to tell the definition for rational numbers in two different ways. First one is the number which are in the form of p by q are called the rational numbers where denominator q is not equal to 0. Already we have learned that. So by using decimal expansion we can tell the definition of rational numbers very easily. How it is? A number which has the decimal expansion is either terminating or non-terminating recurring decimal are called rational numbers. Otherwise, that is irrational number definition. The number which are not rational are called irrational numbers. The number which are not in the form of p by q are called irrational numbers. The two definitions. And the third one, by using decimal expansion, a number which has the decimal expansion is non-terminating non-recurring are called irrational numbers. ఏవైతే రేషనల్ కాదో అవి రేషనల్ నెంబర్స్. ఏ డెసిమల్ నెంబర్స్ p by q ఫామ్ లో ఏ నెంబర్స్ p by q ఫామ్ లో ఉండవో అవి రేషనల్ నెంబర్స్. ఏ నెంబర్స్ యొక్క డెసిమల్ ఎక్స్పాన్షన్ నాన్ టెర్మినేటింగ్ నాన్ రికరింగ్ అవుతుందో అవి ఇర్రేషనల్ నెంబర్స్. ఓకేనా? సో we have to keep mind these points, these definitions. If somebody asks you what is the definition for rational numbers, don't tell in a direct way the numbers which are not in the p by q. So we can use in a different way. Different way is like this: the number which has the decimal expansion has a terminating or either terminating or non-terminating non-terminating recurring decimals are called rational numbers. If you tell like this, so we can that means మీరు చాలా హానెస్ట్గా కనపడతారు వాళ్ళకి. సో ఈ వీళ్ళకి చాలా సబ్జెక్ట్ ఉంది అనే ఒక మీనింగ్ తెలుస్తుంది వాళ్ళకి. సో యూ క్యాన్ యూజ్ లైక్ దిస్. సో నార్మల్ వే కాకుండా యూ కెన్ యూజ్ ఇన్ ఎ డిఫరెంట్ వే. Both are correct. The first definition is usual definition. Everybody is telling the definition. If you tell the second definition, you are like different. Okay? That irrational numbers. I am telling you that definition for irrational numbers is three definitions, which are not rational or irrational, which are not in the form of p by q, and these two are the usually everyone using. Usually everyone is telling that these two definitions. If you are trying in a different way, a number which has the decimal expansion is the non-terminating non-recurring is called irrational number. ఏ డెసిమల్ నెంబర్ ఏ నెంబర్ కి అయితే డెసిమల్ ఎక్స్పాన్షన్ నాన్ టెర్మినేటింగ్ నాన్ రికరింగ్ ఉంటుందో అలాంటి నెంబర్ ఏమంటే irrational number. So now I am concluding this. Terminating decimals and non-terminating recurring decimals are rational numbers. These two are the rational numbers. We can write in the form of p by q. We cannot write these numbers in the form of p by q. These are the irrational numbers. So already we have discussed terminating decimals in the form of p by q. వీటిని terminating decimals ని p by q form లో ఎలా రాయాలో మనం already discuss చేసాం. So now we are learning non-terminating recurring decimals. What are non-terminating recurring decimals? Already in the previous class I was explained. So I am explaining again. Non-terminating recurring decimals are, for example, I am writing 1 point. I am writing the number 5, 5, 5, 5, and so on. It has no end. So if you observe the number, is this decimal number? Yes, it is a decimal number. Why? Because it has a decimal point. So it has in the decimal point there is a number 5, and we have observed there are some dots here. This is called etc. That means no end. It is going away. It is going in that way. That means 5 is repeating continuously. Where it is end? No, there is no end. It is moving in that way. It's moving in that వేలో వెళ్తూనే ఉంటది. This is called non-terminating recurring decimal. The word recurring means repeat. The word recurring means repeat. If you observe this decimal number, this is 1 point. This is, first of all, this it has no end. That's why it has no stop. That means it is non-terminating. Non-terminating means non-stop, no stops. And recurring means that in the decimal part, the digits are either one digit or the set of digits, either 2 or 3 or 4. The set of digits are repeating continuously. The set of digits are repeating continuously. Then the decimal number is called non-terminating recurring decimal. Did you understand? So we are writing this is in a simple way, that is 1.5. 5 is repeating continuously. We can keep a one line to the upside of the 5. We call as this is 1.5 bar. 1.5 bar. This is the non-terminating recurring decimals. Usually non-terminating recurring decimals are by using bars. We are writing non-terminating recurring decimals using bar. For example, I am telling you one more example, that is 12.151515 and so on. So it is also non-terminating recurring decimal. There is no end, that's why non-terminating. For 15 is repeating continuously, so this is a recurring decimal. We are writing this is 12.15 bar. So another example I am writing 0.751 and so on. This is also non-terminating recurring decimal. Why? Because it has no end. If it has no end means non-terminating. Recurring means repeating continuously. So we are writing 0.751 bar. So we can keep the bar for which term, which digit or which set of digits are repeating. For example, here only 5 is repeating, that's why we are keeping only bar for 5. Here 15 is repeating, we can keep the bar for 15. So here 0.751 is repeating, that's why we can keep the bar for 751. Otherwise, for example, if you see like this 15.1577777 and so on. If you observe this example, here in the decimal part there are the digits 1, 5 and 7. But here 7 only repeating, remaining 2 are non-repeating. So we can write here 15.157, which is repeating here 7 only repeating. That's why we can keep the bar for only 7. We can keep the bar for only 7. These type of decimals are called as non-terminating recurring decimals. When you are writing the notes, keep the side heading for non-terminating recurring decimals. The definition also in our CW. You can write the definition, and we have to write the example. I wrote you on the board on 4. We have to write the 5th example also. Do you understand, my students? So we have to keep the heading for non-terminating recurring decimals. Write the definition by using our textbook. And write the examples, 5 examples. I wrote 4 on the board. You can write 5. So if you are not willing to write my 5 examples, you can write your own. You can write your own. Okay. Now I am telling you 2 words. Those are period and periodicity. Those are 2 words. Those are the 2 words, period and periodicity. Period and periodicity. I was explaining in the last class already, but I am explaining again. Period means here, if you observe the first example, 1.5 bar. Which term or which digit or which set of digits are repeating here? 5 is repeating. That's why in the first question, period is 5. Which term, which digit, sorry, actually not term, which digit, either 1 digit or 2 digit or 3 digit. 1 digit is always single digit, 2 or 3 are we called as set of digits. Which digits are repeating is called period. The periodicity is how many digits are repeating or how many set of digits are repeating. That means here only one digit 5 is only repeating. That's why here periodicity is equal to 1. Period is equal to 5. Periodicity is equal to 1. So if you observe the second example, here period is equal to 15. Why? Because 15 is repeating here. The periodicity is equal to, we are writing 2. Why? Because the two terms are repeating. Here the period is equal to 751, comma, periodicity is equal to only 3 digits are repeating. Periodicity is equal to 3. Here period is equal to 7. Periodicity is equal to 1. This is the topic of non-terminating recurring decimals. When you are writing notes, write the definitions for period and periodicity. So we have to. So if you write the 5 examples here, so you can write what is period for that question for your examples and periodicity for your examples. You can write neatly. Okay. Did you understand, my students? Non-terminating recurring decimals. Non-terminating recurring decimals. Okay. Now we have to learn how can we convert non-terminating recurring decimals into rational form. That means in the form of P by Q. Can we, first of all, can we convert non-terminating recurring decimals into P by Q form, into rational form? Yes, we can. We can. How it is? We are learning. So the question is, for example, express the question is as 0.125 bar for 125 in the form of P by Q, where denominator Q is not equal to G. So they are asking the question, express 0.125 bar in the form of P by Q where Q is not equal to 0. Not only like that, they can ask express 0.525 bar, 0.125 bar in the form of rational and express as a rational. They can ask. So now we are taking. It's very easy, very easy. Observe on my words and look at the board. What I am explaining. So our number is 0.125 bar. So we are taking this number is x. We are taking let x is equal to, so I can write neatly. We can write we are taking let the value of 0.x25 bar is x. We are taking as x. That means I am writing x is equal to 0.125 bar means 125, 125, 125 and so on. Am I right? I am expanding 0.125 bar. 125 bar means 125, 125, 125, 125, 125 and so on. Now I am taking, this is the equation number 1. That is the equation number 1. So if you observe 0.125, what is the periodicity here? What is the periodicity for 0.125 bar? That is 3. The periodicity is 3. Why? Because how many digits under the bar? How many digits are repeating continuously? There are 3 digits. The periodicity is 3. Are you okay? The periodicity is 3. So we can divide, we can multiply. So now we are ready. Multiply with 1000 on both sides of equation 1. Equation EQ. Equation 1. Sir, how can you tell that, sir? That means we know already. That means, for example, 0.5. So we can multiply with a number, it becomes 5. How it is? So how many digits are there in the right side of the decimal point? 1. So we can multiply with 10. 0.5 into 10 is equal to 5. The same way, 0.05 into 100 is equal to, for here 2 digits you can multiply with 2 zeros. The same way here 125 means 3 digits, we can take 3 zeros at a time, we are getting 1000. So we can multiply 1000 with 1000 on both sides of equation. We can multiply. So here I am writing 100 into x is equal to 1000 into x is equal to 1000 into 0.125 125 125 and so on. Now multiply 1000 into x is equal to 1000x. So we are multiplying with 3 zeros. The decimal point move on to 3 places to right side. For example, if you multiply with 2 zeros, it's move on to the 2 places. 1 0 1 0 1 place. 4 zeros 4 places. That's why the number becomes 125.125 125 125 and so on. This is equation number 2. That is called equation number 2. Now I am doing subtracting 2 minus 1. I am taking the first equation as 1000x is equal to 125.125 125 125 and so on. The first equation is x is equal to 0.125 125 125 and so on. Now I am subtracting these two equations. 1000 minus x is equal to 999x is equal to, now 125 minus 0 is 125 point, here 125 125 125 means 0. So then x is equal to now 125 by 999. If you have any common table, you can cancel. So 125, there is no common table. 120 will not cancel by 20. So this is in the form of p by q, where denominator q is not equal to 0, where q is equal to 999. Did you understand, my students? Did you understand, my students? I hope you understand. If you can't understand, I will explain one more problem in this method, so you can understand that. But I will then I will give the homework to you. So if you observe here, x is equal to 0.125 bar, 125 bar, not 125 bar, 125 bar. So I am writing, taking the value is x. So 125 125 is repeating. I am writing 125 125 125 125 and so on. So here periodicity is 3. Why? Because the 3 digits are repeating. So that's why I am multiplying with 1000. 1000 into x is equal to 1000 into something. 1000 has 3 zeros, so it's move on to the right side of 3 places. I am getting 125 point something. So I am subtracting these two. I am getting x value 125 by 999. That is the question. That is the answer for the problem. So you can write the notes. Okay, shall I erase this? Okay. Now the second question I am giving you. So this time we are doing (1.3 bar). This is very easy. You can solve 1.3 bar. This is very easy. So you can look at the bar. We can solve. So x plus 1.3 bar in the form of p by q. It's very easy. How can solution? We taking, let x is equal to 1.3 bar. Okay. So I am taking x is equal to 1.33333 and so on. This is called equation number 1. What is the periodicity here? Is it 3 or 1? How many digits are repeating? Only one digit is repeating. So periodicity is equal to 1. Now writing here. Periodicity is equal to 1. So multiply with how much? Either 10 or 100 or 1000. Only one digit. So 10. If 1 has 10 means 10. Multiplying with 10 on both sides of equation 1. So that means 10. So you can do directly. Why? Because we are the IT students. 10 into 1 is equal to 10x is equal to. So if you multiply 10, the decimal point comes to move on to the right side of one place. That means 13.3333 and so on. This is equation number 2. Now I am subtracting 2 minus 1. 2 minus 1. So I am not writing like that. So shall I write? This is the second problem. That's why I am writing. After that I won't write. You have to don't write. That means 10x is equal to 13.3333 and so on. What is 1? X is equal to 1.3333 and so on. You are subtracting these two. 10x minus x is equal to 9x is equal to 13 minus 1 12. 13 minus 1 12. These are the 0. That means x is equal to 12 by 9. If you cancel the 3 table, x is equal to 4 by 3. That is the answer. I think you have understood this step. Am I right? So nothing is done. So I will give you some problems for homework here, and you have to do the sum. I will give you some problems how to do in your CW. In this homework and in your CW, write the 2 problems as it is first of all. And now I am giving some problems to you, either from our textbook or my own. So these problems you can decrease the number of steps. Don't take this much of steps. You can write first of all. So మనం ఈ సమ్ అబ్జర్వ్ చేసాం అనుకోండి, ఇన్ని స్టెప్స్ రాసి మనం సమ్ చేయని అవసరం లేదు. ఇన్ని స్టెప్స్ రాసి ఇంత పెద్దగా సమ్ చేయని అవసరం లేదు. మనం జాగ్రత్తగా అబ్జర్వ్ చేస్తే కొన్ని స్టెప్స్ తగ్గించవచ్చు, డైరెక్ట్గా రాసేయచ్చు. యూ కెన్ యూజ్ లైక్ దట్, యూ కెన్ డూ లైక్ దట్. అలా మనం షార్ట్ కట్లో మీరు షార్ట్ కట్ ఫామ్ చేసుకుని మీరు షార్ట్ కట్లో చేయగలిగితే మీకు చాలా కాలం ఈ సబ్జెక్ట్ గుర్తుంటుంది, దీనివల్ల యూజ్ కూడా ఉంటుంది. ఓకేనా? చూడండి ఎలా అంటే x is equal to 1. ఇది రాయన అవసరం లేదు, డైరెక్ట్ x is equal to 1.33. పీరియాడిసిటీ ఏంటి మైండ్లో అనుకోండి, రాయకండి ఇక్కడ. హియర్ పీరియాడిసిటీ 1. సో మళ్ళీ రాస్తాను మల్టిప్లై విత్ 10 ఆన్ బోత్ సైడ్. ఇవి రాయొద్దు, మైండ్లో పెట్టుకోండి. హియర్ పీరియాడిసిటీ 1 కాబట్టి 10తో మల్టిప్లై చేస్తే వస్తుంది 10x is equal to 13.333. తర్వాత సబ్ట్రాక్ట్ చేయమని డైరెక్ట్గా చూసి చెప్పండి. 10x minus x 9x is equal to 13 minus 1 12. సో 3 క్యాన్సిల్. 12 x is equal to 12 by 9 4 by 3. అలా డైరెక్ట్గా చేయగలిగితే మీకు ఈ పర్టికులర్ కాన్సెప్ట్ మీద మంచి గ్రిప్ వస్తుంది. ఓకేనా? ఇలా పెద్దగా సమ్ చేయవలసిన అవసరం లేదు. వీఆర్ ఐఐటి స్టూడెంట్స్. ఐ థింక్ యూ నో వెరీ వెల్ అబౌట్ దట్. వీ కెన్ సాల్వ్ వన్ ప్రాబ్లమ్ ఇన్ లెస్ దాన్ 30 seconds. 30 seconds లోపలనే ఒక బిట్ ఆన్సర్ చేయాలి. మనం ఇదేంటి చిన్న ప్రాబ్లం, జస్ట్ వెరీ వెరీ స్మాల్ ప్రాబ్లం. ఈ సమ్ మన టైం తీసుకునేంత నీట్గా రాయని అవసరం లేదు. ఓకే? బట్ వీ హ్యావ్ టు రైట్ ఫస్ట్ 2 ప్రాబ్లమ్స్ లైక్ దిస్ ఇన్ యువర్ సిడబ్ల్యూలో మాత్రం ఫస్ట్ 2 ప్రాబ్లమ్స్ ఇలాగే రాయండి. ఎందుకంటే మనకి అసలు మెథడ్ ఏంటో తెలియాలి, తర్వాత షార్ట్ కట్ అప్లై చేయాలి. Are you okay, my dear students? Note on this one. Okay. Now, if you observe your textbook, open your textbook, page number 15. That is, there is a side heading for method of expressing recurring decimals as rational numbers. అంటే ఈ నాన్ టెర్మినేటింగ్ రికరింగ్ డెసిమల్స్ ని p by q ఫామ్ లో రాయడం ఎలా అనే విషయం గురించి కొంత మ్యాటర్ ఇచ్చాడు. సో you can easily understand that matter. So you can read that. So they have solved one problem by examples. If you like this matter and if you able to follow this formula and the problem, you can solve like this. So for example, most of the students, they can easily forgot the formula. Why? Because if you observe the formula, once you get recurring decimal is equal to the whole number obtained by the writing the digits in their order minus the whole number made by the non-recurring decimals in order into the number of digits after the decimal point minus the number of digits after the decimal point do not occur. Actually, we have to use the divided by between the whole number made by the non-recurring decimals in order divided by the number of digits after the decimal point. So it is very easy, but if you want to మీరు అది ఫాలో అవ్వగలను అనే మెథడ్ మీకు అనిపిస్తే you can follow that. లేదు అనుకుంటే what I have explained in the board you can follow. Are you okay, my dear students? Now we have to come on to the hand sheet number 3. Actually this is a hand sheet number 3. For ours this is the hand sheet number 1. So I am explaining these the problems in this hand sheet. So if it is very easy, I will give the homework. You can do the homework first. Answer get the first. 0.06 is equal to dash. So this is also homework. Do in your CW. Actually this is the homework, but you can do in your CW. 0.06. 0.06. How can we write in the form of P by Q? 0.06 is equal to, there are 6 by, how many digits are there in the decimal part? 2. So 6 by 100. If you simplify that, you will get the value. What value? Which value have you get? Yes, option 4 is the correct. 3 by 50. Next. Which of the following are irrational numbers? Which of the following are irrational numbers means, so we know that root 4 is, the value is 2. Yes, it is a rational number. 1.5, it is a terminating decimal. Terminating decimals are rational numbers. So option 3 also correct. Option 4, 1.5 bar. 1.5 bar is non-terminating recurring decimal. This is also a rational number. But the irrational numbers is root 5. I told you when I was explaining the definition of irrational numbers, if you apply the root for non-perfect squares. Non-perfect squares means 1 is a perfect square. 2, no, not a perfect square. 3, not a perfect square. 4, yes, it is a perfect square. 5, no. 6, no. 7, no. 8, no. So if you apply the square root of non-perfect square numbers, we can get irrational numbers. We can get irrational. That's why 5 is a, and the second thing is, if you apply the root for prime numbers, if you apply the root for prime numbers, the number is an irrational number. 5 is a prime number. If you apply the square root to the 5, it is an irrational number. Next, third example. Convert 0.375 bar in the form of rational form. You can do the sum. You can do the sum for. You can do in your CW. Write the answer in your CW. Tick mark. Keep the tick mark in your textbook. Okay, now? So 3.75 bar. 3.75 bar. What is the periodicity? There is a bar for only 2 digits. 75. Periodicity is 2. 2 means we can multiply with 100. We can do. Can you solve? Yes. Next. The periodicity, the period of 7.15 bar. 7 by 15. 7 by 15 means, so we can divide 7 with 15. First of all, I am explaining fourth problem. Fourth problem is, they are asking period for 7 by 15. We can divide 7 with 15. 7 with 15. You can get here the decimal, the non-terminating recurring decimal you can get. So they are asking period. Period means which digits are repeating, either which digits are repeating. So you can solve and you can write the answer. Next, which of the following is not a terminating decimal? I told you terminating decimal. Terminating decimal means the decimals these are in the form of P by Q, where the denominator Q has either only 2's or 5's or their combination. 2 into 5. I told you 2 power m n into 5 power m. I told you, I explained to you. So first of all, you can solve 8. First of all, 3 by 8. 3 by 8. Right? Factorize 8 in the form of 2's and 5's. 8 is 2 cube and also 75. Right in the form of either 2 into 5 or either only 2's or 5's. So if you are getting only 2's, it is terminating decimal. If it is only 5, it is a terminating decimal. The combination 2 into 5, it is also terminating decimal. If you get any other number extra, it is not a terminating decimal. It is not terminating decimal. Have you understand? It was explained already. I mean, already explained chesane oralga cheppestunanu. Next. Which of the following rational number between minus 1 by 2 and 1 by 2? I can tell you the sixth one. I am explaining the sixth problem. The sixth problem is which of the following rational numbers lies between minus 1 by 2 and 1 by 2? It's very easy actually. I want to explain this method, but there is no syllabus in our textbook, that's why I would explain you. But we can solve this problem. First of all, minus 1 by 2, minus 1 by 2. So this is minus 1 by 2. If you convert in the form of decimal expansion, this is minus 0.5. 0.5. 1 by 2 is 0.5. The same way, 1 by 2 is equal to, this is 0.5. They are asking, here 0.5 is there, here the between so many rational numbers, so many means these are infinite rational numbers are there, between two rational numbers. So here 0.5, they are asking, they are giving some options, which rational number between these numbers, minus 0.5 and 0.5. Minus 0.5 ki plus 0.5 ki మధ్యలో ఉండే rational, మధ్యలో అంటే exact middle లో అని కాదు. సో ఆ రెండిటికి మధ్యలో ఉండే rational number ఏంటి అని అడుగుతారు. We can solve by option. The first option, they are giving 3 by 10. The first option is 3. They are giving first option is 3 by 10. If you convert 3 by 10 in the decimal form, 0.3. Is 0.3 between 0.5 and minus 0.3? Minus 0.5 ki 0.3 ki మధ్యలో 0.3 ఉంటుందా? Yes, this is correct. Now the second option is 0. Is between 0.5 and 0.5? Yes, it is also correct. Now the third option. The third option is 21 by 100. 21 by 100. You can convert into decimal form. How it is? 0.21. This is also between these two numbers. And fourth option is 2 by 3. We can convert 2 by 3. 2 by 3 in the decimal form. 0.6. Why? Because if you keep the 0 here, this is 20. 6 3s are 18. 20 again 6. That means 0.6 bar. 0.6 bar is between 0.5 and minus 0.5 and 0.5. Not correct. So the options for the question is 1, 2, 3. So if you observe the heading, this is multi-correct choice type. That means either more than one answer is correct. Not only one answer. First Roman single choice correct answer. There are in that Roman there is only one answer is correct. In the second Roman, 1 or 2 or more than 2 answers is correct. So if you observe this example, 1, 2, 3, the 3 options are correct. Now coming to the seventh problem. Seventh problem is period of 7 by 11 is 81. You have to write I'm just explain. You have to do that problem. So there is a seventh problem is they are giving 9 by 11. You can convert in the form of decimal form. You can convert into decimal form. How it is? If you know any tricks you can use. Otherwise you don't know any tricks. You can divide 9 by 11. You can divide 9 with 11. You can get the decimal expansion here. You can get decimal expansion. They are asking what is the period? The period is 81. What a period 81 అని ఇచ్చేస్తున్నాడు. ఆ 81 నీకు వచ్చింది అనుకోండి. Then the first statement is correct. Then the first statement is correct. నీకు 81 రాలేదు అనుకోండి. You can decide the first option is wrong. Now coming to the second option. The number of digits in the recurring part is called periodicity. చూడండి మంచి డెఫినేషన్. మీరు periodicity డెఫినేషన్ నోట్స్ రాసుకునేటప్పుడు దీన్ని యూస్ చేసుకోవచ్చు. The number of digits in the recurring part is called periodicity. Correct. ఎన్ని digits అయితే రిపీట్ అవుతున్నాయో దాన్నే periodicity అంటాము. సెకండ్ ఎగ్జాంపుల్ సెకండ్ స్టేట్మెంట్ ఇచ్చారు. That is correct. So we can go the options. You can take the correct option. Now comprehension type. Comprehension type means I think you know very well about comprehension questions in English. They are giving one paragraph. They will ask some questions. These questions are somehow based. The answers are in that paragraph. The same way, the paragraph is the recurring part of non-terminating recurring decimal is called period, and the number of digits in the recurring part is called periodicity. So now the recurring part of non-terminating recurring decimal లో recurring part repeat అయ్యే part ని ఏమంటామంటే period అంటాం. ఎన్ని డిజిట్స్ అయితే రిపీట్ అవుతున్నాయో ఆ నెంబర్ ఆఫ్ డిజిట్స్ ని ఏమంటామంటే periodicity అంటాం. ఆ విషయం మనకు ఆల్రెడీ తెలుసు, మనం ఆల్రెడీ చదువుకున్నాం. దానికి సంబంధించి ఫస్ట్ వచ్చి the period of 3 by 11. The period of 3 by 11 అనగానే మీరు ఇది 8కి వచ్చారు. 3 by 11 అనగానే ఈ 3ని 11 తో డివిజన్ చేయాలి. 11 తో డివిజన్ చేస్తే ఇక్కడ మీకు డెసిమల్ ఫామ్ వస్తుంది. దానికి పీరియడ్ ఏంటి ఆప్షన్ ఇచ్చే. పీరియాడిసిటీ ఆఫ్ 1/6. 1/6 అనే నెంబర్ 9th క్వశ్చన్లో 1/6 అనే నెంబర్ని 1ని 6తో డివైడ్ చేయాలి. ఇక్కడ మనకి నాన్ టెర్మినేటింగ్ రికరింగ్ డెసిమల్ వస్తుంది. దాని పీరియాడిసిటీ ఏంటో డిసైడ్ చేయాలి. అలాగే 5/13. 10th question is 5/13. 5/13 means you can divide 5 with 13. 13తో డివైడ్ చేయండి, ఒక డెసిమల్ ఎక్స్పాన్షన్ వస్తుంది. దాని పీరియాడిసిటీ ఏంటో రాసుకోండి. సో మ్యాట్రిక్స్ టైప్ క్వశ్చన్స్ 11th question. 0.37 bar for 5. Already we have discussed, I think. So write the answer matching that. 0.25. There is no bar. This is just a terminating decimal. 0.25. You can write 25/100. You can cancel 1/4 is the answer. 1/4 means there are two options. Please be focused. Next 15.02. So we can write in the form of p/q. 1.3 bar. That is also you can do. Next 12th question. The number of 2.52525252 is a fraction. 2.52525252 means 2.52 bar. 2.52 bar. We reduced the lowest. మనం 2.5 bar అని తీసుకున్నాం కదమ్మా. వాడు చెప్పే క్వశ్చన్ అంటే 12th question లో they are giving 2.52 52 and so on. So we have to write this is 2.52 bar. Bar for 52 both. So 52 bar. When reduce to the lowest term, the sum of the numerator, then first మనం ఈ 2.5 బార్ మీరు ఏం చేస్తారంటే p/q ఫామ్ లో మార్చండి. అంటే ఈ అంతా ఇక్కడ చేసాం కదా, పీరియాడిసిటీ 2 కాబట్టి 100తో మల్టిప్లై చేసి మొత్తం p/q ఫామ్ లోకి మార్చిన తర్వాత ఒక ఫ్రాక్షన్ వస్తుంది. న్యూమరేటర్ వస్తుంది, డినామినేటర్ వస్తుంది. దే ఆర్ ఆస్కింగ్ వాట్ ఈస్ ద సమ్ ఆఫ్ న్యూమరేటర్ ప్లస్ డినామినేటర్. Sorry, this is the denominator d. So we are writing d. What is the sum? They are asking what is the sum? The sum of numerator and the denominator is dash. That's all. You can easy. Next 13th question. Which of the following will change to terminating decimal? అంటే కింద ఉన్న వాటిలో ఏది టెర్మినేటింగ్ డెసిమల్? టెర్మినేటింగ్ డెసిమల్ కాదో తెలియడానికి మనం ఇప్పుడు చెప్పుకున్నాం. ఏమని డినామినేటర్ ని 2 మల్టిపుల్స్ తో కానీ 2తో ఫ్యాక్టరైజేషన్ చేయండి. ఓన్లీ 2s, ఓన్లీ 5s లేదా 2 into 5s ఉంటే టెర్మినేటింగ్ డెసిమల్. అలా వచ్చే ఆప్షన్ ఏదో చెక్ చేసుకుని ఆన్సర్ వచ్చేస్తుంది. నెక్స్ట్ సింగిల్ ఆన్సర్, ఒకే ఆన్సర్ కరెక్ట్ ఉంది. నెక్స్ట్ విచ్ ఆఫ్ ద ఫాలోయింగ్ విల్ బి ద కన్వర్ట్ ఇంటూ నాన్ టెర్మినేటింగ్ డినామినేటర్స్ లో ఏది నాన్ టెర్మినేటింగ్ రికరింగ్ డెసిమల్? నాన్ టెర్మినేటింగ్ డెసిమల్ అవుతుంది. నాన్ టెర్మినేటింగ్ డెసిమల్ మీన్స్ నాన్ టెర్మినేటింగ్ రికరింగ్ డెసిమల్. సేమ్ డినామినేటర్స్ ని అబ్జర్వ్ చేయండి. డినామినేటర్స్ ని 2 తోటి 5 తోటి ఫ్యాక్టరైజేషన్ చేయండి. 2లు కానీ ఓన్లీ 5లు కానీ 2లు 5లు కాంబినేషన్ ఉంటే వాటిని టెర్మినేటింగ్ డెసిమల్ అనండి, అలా లేకపోతే నాన్ టెర్మినేటింగ్ డెసిమల్ ఈక్విటీ అయిపోయింది. నెక్స్ట్ 15th. విచ్ ఆఫ్ ద ఫాలోయింగ్ స్టేట్మెంట్స్ ఆర్ కరెక్ట్? ఆ స్టేట్మెంట్స్ అన్ని చదివి దానిలో ఏ స్టేట్మెంట్ కరెక్ట్? మల్టీ కరెక్ట్ ఆన్సర్, దట్ మీన్స్ మోర్ దాన్ వన్ ఆన్సర్ ఈస్ కరెక్ట్. యూ కెన్ డూ దట్ 15th ఆల్సో. నెక్స్ట్ 16th question. I will explain 16th question and 17th question in the next video. So thank you. ఎందుకంటే ఇప్పటికే చాలా సమ్ హోంవర్క్ అయిపోయిందమ్మా, మళ్ళీ ఇది కూడా చెప్పాను కనుక ఒక సమ్ ఎక్స్ట్రా లేదు. So that's why we have to complete up to 15 problems in this video. When you are completed all these problems, send me your answers to my number. Are you okay, my dear students? We will continue the remaining problems and the next topic in the next class. Okay, thank you.